Okay, we are going to start off by graphing the parent of secant. And I realized yesterday on our very last example there was one teeny tiny thing that I forgot to mention on the asymptotes. Very slight oversight. We'll fix it today. So we'll talk about that particular piece. Secant is the reciprocal of what? Yep. Reciprocal of cosine. And when we're talking about cosine, what is the amplitude of cosine? For the parent, just a 1. What is the period? 2 pi. Periods, yeah, it's going to be 2 pi over the absolute value of b. Yes, amplitude is going to be the absolute value of a. So for our parent, it's going to be 1. 2 pi over the absolute value of b. So for the parent, it's going to be 2 pi. Left endpoint, right endpoint. What are we looking at? What do we set them equal to? Left endpoint 0, right endpoint is 2 pi. And then we have our asymptotes. Let's graph our parent cosine so then we can see where our asymptotes are going to fall. Okay? What does cosine look like again? Yep, cosine's in show choir. Sine looks like an S on its side. Let's label our x-axis by pi over 4s. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. And I go ahead and reduce all of mine down. If you don't want to reduce yours, that's fine by me. I need to see what you're counting by, and I need to see that you put stuff in the right spot. So remember, we're going to do like our ghost of a cosine function in the background. It's not actually what I'm graphing, because that's not my secant graph. It's just helping me figure out where my asymptotes go. Where are my high points and my low points? So where's my first point going on here for my ghost of a cosine? At 1, and where on the x-axis? 0. So 0, 1. That's my left endpoint. Right endpoint goes all the way over at 2 pi, and it's also a high point, right? So it's going to be at 2 pi and 1. Those are my two maximums on cosine. Where's the minimum? Pi. And how far down do I go? I go down 1 below the x-axis, so down at -1. Where do we cross the midline at? Pi over 2 and 3 pi over 2. So here's my ghost of cosine. And I need another whole period of that. My asymptotes are going to be where I'm crossing that midline at, which is happening where with this? Pi over 2 and 3 pi over 2. And so it would also be occurring on the negative side at negative pi over 2 and negative 3 pi over 2. When I define where these asymptotes are, if I'm not starting right on the y-axis, then I need to name at least one asymptote and then explain how far over I would count to get to the next one. Because basically, whatever we put in for n, whatever whole integer we put in for n, if I calculated that out and simplified it, I should be able to go there on the x-axis and be like, yep, there's an asymptote right there. So usually what we do is we name the first one that is to the right of the y-axis. Where's our first asymptote to the right of the y-axis? Pi over 2. So I have an asymptote at pi over 2. How far from pi over 2, hold on, it's going to be a jerk on me. Okay. How far from pi over 2 would I count then to get to the next one? How many little lines over? 4 little lines over, and we're counting by pi over, thank you. We're counting by pi over what? 4. So if I go 1 pi over 4, 2 pi over 4, 3 pi over 4, that's 4 pi over 4, right? Which reduced down to pi, 1 pi. And every time I go 4 more little marks over, there would be another asymptote there, right? Because it's this repeating pattern. So I would put the n next to the pi. You're welcome. Name where one asymptote is, and then it's plus however far you have to go to get to the next one. We included this idea when we were talking about domain of the very last graph that we did yesterday, but we just forgot to include that piece on the asymptote part.
And then we draw the parabola.
Yep, now we're going to draw our little parabola thingies. This one's going to go down. This one goes up. Do I have 2 full periods if I leave it just like this? No. How many U's would I need in total? So how many total little parabola thingies do I need in order for it to be 2 full periods? 4 of them. Right now I've got 3. Well, over here, got like a half of one, right?
Close enough.
Yeah. I could draw the other side of it in if I wanted to.
I have a question. Like,
Yep.
say like you did like a half a parabola on that side and the other half would that count too?
Yep.
Oh, okay.
I would accept that right there. If you, I need at least 2 periods, so if you want to go a little further, if you wanted to draw in the other asymptote over here so that you could complete this side out, I would accept that. Or I would take it if you just do the little 2 halves, because if I put 2 halves together, I get 1 whole, right? This would be 2 periods right here. As long as I see 2 full periods, I'm good. How would I define the domain? Yep. All real numbers, except yep. X doesn't equal where my asymptotes are, so pi over 2 plus pi n. What about the range? Negative infinity to negative 1, bracket, union, 1 to positive infinity. Beautiful. Let's do a transformation. So now that we've learned how to do both secant and cosecant, we're going to have to pay attention at the beginning. Did they tell me secant so that my ghost in the background is cosine, or did they give me cosecant so that my ghost in the background is sine? Because that affects where my high points and low points are going to be, and it affects where my asymptotes are going to fall. All right. You need me to go back?
Yeah.
Yep. Okay. Let's start off with the easy things. What's the first thing I would want to put on my graph here? K. Midline shifts up 1. See ya. You as well. So we're going to shift that midline up. What's my amplitude? 1. What is our period? 4 pi, because I have 2 pi divided by 1/2, so 4 pi. We want the ghost of who? Cosine, reciprocal of cosine. So we're going to do our left and our rep. Left endpoint gets set equal to 0. 1/2 x minus pi over 2 equals 0. So 1/2 x equals pi over 2. Where's my left endpoint going? Pi. And my rep, my right endpoint, we're going to set that equal to 2 pi. When I add pi over 2 to both sides, what do I get? Five pi over 2. So right endpoint is? 10 pi over 2, which is 5 pi. Knowing what my period is, 4 pi, looking at where my left endpoint and right endpoint are going to be, should I count by pi over 4s? No. What should I count by? I can count by pi's or pi over 2s. Pi over 2 is the first thing I heard, so I'm going to go with that. If you want to count by pi, you should be able to see the whole thing. Make sure that you don't pick things that are too close together or your graph ends up too squished and it's hard to graph it then. So I'm going to count by pi over 2s. So pi over 2, 1 pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, and there's my 5 pi right at the end. So I can definitely fit it on here. We said we're doing the ghost of cosine in the background. So do I start on the midline, above the midline, or below the midline? What'd you say?
I said above.
Above. I just couldn't hear you. It sounded like you said because I can't differentiate sounds super easily. So we're going to start above. What is my amplitude? 1. So for left endpoint and right endpoint, I'm going to be 1 above the midline. Because cosine, show choir. Where's my low point? 3 pi. Oop, too far. Just 1 below the midline. And then we're going to cross our midline at 2 pi and 4 pi. Get 2 full periods on there. Did I do that right? Yeah, I just made it look goofy over here. Where are our asymptotes at? 0, 2 pi, 4 pi, negative 2 pi. So defining those asymptotes. Do I need to have something plus pi whatever, or can I just get away with defining things with the n? Just with the n. Why? I have an asymptote that starts right on 0, so I don't have to worry about any kind of shift on that. How far from 0 to my first asymptote? 2 pi, and every 2 pi after that, right? So my asymptotes are at 2 pi n. Let's get our graph going on here with little parabola thingies. That's horrible. And so what would my domain be? Yep, all real numbers except x cannot be 2 pi n. What is my range? Absolutely correct. Negative infinity to 0 because we had that upward shift. Union 2 to infinity. Beautiful work so far. I don't even have a spot to sit today. Got too much going on. All my classes kind of have different things going on today, so I have like all these different supplies out, and my desk is a disaster area, and it's driving me nuts. All right. Here we go. Do I need a midline shift? No. What's my amplitude? Close. My amplitude is 1, because remember it's the absolute value of -1. So my amplitude is just 1. What is my period? Pi. Yep.
So the negative does nothing because it's cosine?
Negative will do something to it, because the negative's out in front. If it's inside the, if it's my angle, then you're right, it wouldn't do anything. But it's out in front here. That's exactly what it's going to do. Ghost of who? Cosine. So I need my lep and my rep. Left endpoint, set it equal to 0. Right endpoint, set it equal to 2 pi. 2x plus pi equals 0. So I'm going to have 2x equals negative pi, which means my left endpoint is where? Negative pi over 2. It is okay to have negatives as my left endpoint. You might even, and like if it shifts far enough to the left, you could have a left and a right that would be negative. Right endpoint, 2x plus pi equals 2 pi. I'm going to subtract pi from both sides, so 2x equals pi. My right endpoint is at positive pi over 2. If I count by pi over 4s, can I fit 2 periods on here? I should be able to, because my period is just pi, right? So if I count by pi over 4s, I should be able to fit 2 full periods here. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. I'm going to go backwards just a little bit since my left endpoint is at negative pi over 2. In relationship to the midpoint, or the midline, am I going to be above, on, or below for my left and my right?
Below.
Why?
Because there's a negative.
Because there's a negative out in front. We are reflected. So we're going to start out below the midline instead of above. Normally cosine is up here. For this one, we're down here. And I'm going to fall. I feel like I need a sparkly dress for some of this. Okay, so we're below on both of those. Where's my high point then?
0.
0. Do you guys want the second period to go to the left or to the right of this? Sounds good to me. Where am I putting my asymptotes at? You said what? Pi over 4. Where else? Negative pi over 4. Well done. Awesome. 3 pi over 4. And 5 pi over 4. Do I have an asymptote that falls right on the y-axis? No. So if I don't have an asymptote that falls right on the y-axis, I've got to name one of them and then do plus and then however far over I count to get to the next one. Give me the first one to the right of the y-axis. Pi over 4. Plus, so let's start there. We're counting by pi over 4s, right? So then 2 pi over 4 and I get to the next one.
Would you do plus or minus?
I would do just plus because remember the n can be a positive or a negative.
No.
So 1 pi over 4, 2 pi over 4, does that reduce? Reduces down to what? Pi over 2. N. The reason I don't do plus or minus is mainly just to simplify it and streamline it. Because if I put a negative 1 in here, then I would be subtracting it. Or if I put a negative 5 in here, I would be subtracting it.
Okay.
So as long as it is an integer, positive or negative integer, that will tell me the location of every single asymptote. Let's get our graph sketched in here. So we're going to go down over here. Right about the y-axis, we're going up. Going down here. Going up over here. And going down. What is my domain? That's exactly correct. All real numbers except x cannot be pi over 4 plus pi over 2n. And our range. union 1 to infinity. Love it. All right. Let's get another one up there.
So are we doing not tangent and cotangent today?
We're going to try to introduce tangent. Yep. Probably won't get to cotangent until tomorrow. Do I need a midline shift? No. What is my amplitude? 2. What is my period? Pi. Ghost of who? Sine. All right, I want you guys to do this one, and then we'll compare your graph with mine.
Oh, goodness. How does this start this?
Because of where the left endpoint and right endpoint fall, I would count by pi over 6s. This is where knowing your unit circle is really, really helpful. I counted by pi over 6 as yes.
So why is the pi right after the
What am I doing?
3?
That should be pi over 2. My bad. Thank you. And so this would be pi.
Oh, I'm confusing myself. So is this correct
Yeah,
so far?
that was my bad. 1 pi over 6, 2 pi over 6, 3 pi over 6, yes. And then, because 2 pi over 6 would reduce.
to 1 pi
1/3,
over 3, and then this one would.
That'd be 3 pi over 6, which reduces.
I'm definitely. I'm right, but I'm definitely confused.
So, let me draw the last circle. One pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, that one doesn't reduce.
Yeah.
6 pi over 6,
Which would be pi.
7 pi over 6, 8 pi over 6,
4.
9 pi over 6,
3,
10 pi over 6,
2. Okay.
11 pi over 6.
Definitely hurts my head, but alright.
But I'm just thinking, like, as I count my way around, it's easier to count those numerators as like 1, 2, 3, 4, 5,
Yeah.
and then reduce
start
things.
reducing.
If you think about where you are on the unit circle, reducing them gets a lot faster.
Yeah, I'll just. I think I was reducing in my head. That's how I'm gonna mess this up.
Mm-hmm. It was really funny. Every calculus class I ever took, because there's, Calc 1, Calc 2, Calc 3, you'd watch people during the test, they'd stop, they'd look up, and they'd be like, and then they'd write a number down. And you're like, and then they'd just like, thank you, Rachel, for catching that mistake. So negative infinity to negative 2, union 2 to infinity.
Cool.
Yes, sir.
So if there was a pre-algebra and there's a pre-cal, what happened to pre-geometry?
Because geometry is useless.
And geometry is not useless. What do you think this is?
Yeah. Geometry is just a more advanced version of geometry.
As far as pre-geometry goes, for the most part, they have tried to integrate a lot of that into like some of the lower level courses.
Geometry just be the stuff we learned in elementary school.
Yeah.
Miss Bo, I have to tell you. So, you know those triangles that I was like, you did that. So my brother yesterday, he comes in, he's in geometry and he's at New Augusta. So he was like, I wasn't there at school the day that they're doing it. He has a test tomorrow. His teacher doesn't like him, so he wasn't gonna ask him for help. So then we got into an argument. So I didn't help him last night. But then he texted me this morning. He's like, "Can you please explain it to me?" And so I sent him just a picture of the thing he did. And he's like, "Thank you so much. You saved my grade." Because it was like the 90, 30.
The 30, 60, 90s
Yeah,
and
then
45, 45, 90s. Yep.
That's exactly what it is.
Okay. Other than the fact that I initially labeled the x-axis wrong, but I fixed it. Do you guys have any questions about how this turned out? Yeah, we'll probably get to tan and cotan tomorrow. Because there's one more that I want to look at with you that's along these lines. And it throws in something else fun from algebra. You know how when we were verifying and simplifying, sometimes we had to use factoring there? So all the stuff that you know from algebra can come back to haunt our trigonometry dreams. I'm going to put the next example up.
Oh.
Why are y'all like this? I cannot stand this class.
I love you too, Maya.
I love you, but you are not the problem, but this class is the problem.
Oh. And if I didn't prepare you for it, how good of a teacher would I be then?
You're the best teacher ever. We absolutely love you.
Oh, thank you. I love you too. Let's get our midline shift in here first. I know I need the ghost of who? I need the ghost of cosine. With a twist. Because it's not just ghost of cosine, it's ghost of absolute value of cosine. What does absolute value do to my numbers? Makes them positive. So no negatives, which means I'm never going where? Yeah, I'm never going to go below the x-axis. Whatever that distance would be, now I'm going to reflect it up. Other than that, it's just like the parent of cosine other than this shift, right?
So how would you do that?
Well, let's talk about it. I know my amplitude is going to be 1. I know my period is going to be 2 pi. My left endpoint is just 0. My right endpoint is just going to be 2 pi. Because I've got x equals 0, x equals 2 pi. When we think about cosine, cosine looks like what? Absolutely. Oh, I'm going to have you guys dancing by the end of the week. Choreography, courtesy of trigonometry. Cosine's up like this. That's where my left endpoint and my right endpoint are going to be. Is that a problem when I'm thinking about absolute value if they go up like this? Nope, because that's positives. So I'm going to go above my midline, up 1. I should probably label my x-axis.
Are we required to label?
I need to see enough labels that I know what you're counting by. Like if you labeled it this far, I can see that you're counting by pi over 4s. We're good. Okay.
Well, the dip isn't even going to reach the x-axis.
But remember, I'm going based on the midline.
Oh.
I can't go below the midline since we shifted up. Because the absolute value gets applied to it before you add or subtract anything. Order of operations, right?
So you're just going to reflect the amount that came from the bottom?
That's exactly right.
Oh, that's whack.
Okay, so I know, don't actually graph this next point, okay? Just watch what I'm doing. I know that the parent cosine would normally come down here. That's not going to be allowed, right? And then I would be crossing my midline here and here. This one's not allowed to be down there. It's going to reflect up, which means it would be where? On the other side right there. It would come down like this. And normally it would go like this, but that's going to reflect. So it's not doing that. It's basically going to bounce. It's going to look like it's this bouncing ball.
So you don't want like the curves on when it gets to the middle?
It's not going to actually curve because think about what that reflection would look like. Normally it would be arced down like this, so if I take that and I flip it over, does that make sense?
Yeah, would you take off points if I curved it on accident?
On accident, no, because technically this guy is just a ghost in the background.
This guy.
Now no, this guy.
Oh, this guy.
If I asked you to graph absolute value of cos x, I want to see the bounces, because then that's what I'm asking you to graph.
So then what's the difference between this and cosine?
This is absolute value of cosine. Absolute value of cosine or absolute value of sine, it's going to look like it's bouncing along the midline. When it gets to a high point, it's going to curve over, but then it's going to hit the midline, and it's going to bounce right back off. It's kind of like doing back handsprings across it.
I meant, what's the difference between like the absolute value of secant and the absolute value of cosine?
Ah, well, this is my cosine graph. My secant is going to be those U shapes that end up just at the tops.
Ah.
So what's this going to look like when I actually draw the secant graph in there? Do I have any that go down? No, they all go up. Mm-hmm. There we go. My asymptotes are occurring where?
At the top. I mean, what?
Where are my asymptotes?
Pi over 2.
Pi over 2 plus pi n. My domain absolutely correct. And what about my range? Three to infinity. All right.